Rasanya aneh. Ada? Iya. Oke. Okay. So, hello everyone. I welcome you all to the live stream on YouTube on the channel of Fireblaze AI School. As you might have read on our poster, the topic for today is, or the title for the video is Critical Thinking in Data Analysis. The topic you must have read is LA wildfire. That means the wildfires that just took place in Los Angeles. I think you might be aware about this news, wherein there was a huge wildfire in two of the places in Los Angeles. First was named as Palisades, and another is Eaton. So yeah, so the topic for today would be roaming around these two topics or these two places, or the wildfires in Los Angeles. So, but before talking about that, let's talk what is data analysis. So what the this group of data analysts what they do is usually what they do is they have a problem statement. We take the problem statement, we try to extract some data from for it which supports this problem statement, and we try to draw some insights out of it using a few techniques or a few tools that we know. And at the end, we try to visualize it using some graphs or so. So we'll be doing similar kind of thing. I don't think everything would be possible in the span of an hour. So what we'll do is we'll at least start with it and we'll try to get some insights about this wildfires. So let's see. So first of all, abhi, what I'll do is I'll use both the languages. I'll use English as well as Hindi just to be, just to be I mean, there are some people, there was some audience. I got feedback from them from the last live that they also want me to speak in Hindi a bit. So I'll be talking in both the languages so that everyone feels comfortable. Okay, so let's start with this video. So first of all, you might be knowing what a wildfire is. So let me just tell you. So what I'll do is I'll search about this LA wildfires so that everyone gets an idea about what it is. If you don't know, I think it's a huge news. So I guess everyone might be knowing about this. बहुत बहुत ज़्यादा डिस्ट्रक्शन हुआ है इस वाईफाई की वजह से. ओके, हम देखते हैं. लेट्स सी एनबीसी न्यूज़. ठीक है, तो यहाँ पे कुछ बोल रहे हैं वो दैट सी ऑलमोस्ट कंट्रोल ऑफ 40,000 एकर्स ऑफ ऑनगोइंग वाइल्ड फायर. सो मतलब 40,000 एकड़ से भी ज्यादा कि जो लैंड है उस लैंड पे जितने भी हाउसेस थे वो जल चुके हैं. Huge devastation going on. Still, the fire is not contained. मैंने last I heard it was some 65% of the fire was contained. So there's still more fire which is still not contained. So it is huge over there. And it all happened on 7th of January. There were two different places. One is Palisades. So you can see on the screen over here. So the Palisades fire, which was even the larger of these two fires, is just 31% contained right now. Just 31%. That means there's still 70% of chance that this fire may still arise. It is not contained, so it may spread even more. And whereas the Eden fire, which is the smaller one, is 65% contained, but still not completely contained, which raises a lot of concerns. Now you might think, or you might ponder why this might have happened. So, why this wildfire did happen. So, that's what we will try to think today. Um, if we see, uh, the reason for wildfires can be many. There can be many reasons for that. one of which is lightning bolts. Sometimes, because even before that, even before the causes, there's one critical thing that in USA, which is a major cause of wildfire, because for fire you need fuel, right? Right, you need fuel. So where does this fuel come from? So the major thing in USA is that the houses, they are made up of wood. So since they are made up of wood, it is a live tank of fuel, we can say. Even if there is a small fire, the whole house may burn because it is made up of wood. And plus, but again, so one house may be burning, but does it happen that why did it happen? The whole town burned all of a sudden. So there are many reasons possible for that. One is the spreading of fire. So the fire spreads a lot due to heavy winds. And we'll see one by one why these winds arose and what can be the possible reason for it. Okay, so let's take a look at what kind of devastations happened over there. So first is it has killed at least 27 people. The counting is still going on, but it has killed 27 people over there. This fire has killed. And it has destroyed more than 12,300 structures. Can you imagine 12,300 structures? That means there were maybe 12,300 homes. Around tens of thousands of people have been evacuated from the area and have been warned to just stay there. I've also read somewhere that there's going to be this thing. I mean, this warning is still going to be continued till the end of next week because they're possibly saying that there will be some conditions that might lead to even more forest fires again. I know it's very saddening and it's very shocking to see this, but that's the reason. I mean, that's the reason I chose the topic because we as data analysts, what our job is, we need to study this data. We need to know why these kinds of fires or these kinds of disasters happen in the world. If we know the reasons why this happened, we can be well prepared beforehand if we know that the conditions like these are going to form. So same thing happened. The climate authority in California is saying that the same forest, this wildfire like conditions are going to be prevalent in somewhere around mid of the next week. So that is when you have, I mean, the people over residing over in the Southern California have to be prepared for that, right? So let's try to do this analysis from our side. Okay. Okay. So I was roaming on the internet looking for the data if I could find something. I did find one data set. I did find one data set. So what I'm gonna be doing is I'm gonna be seeing that data. Um, just a second. Let me get the data. So this is the data that I came across. It is in Spanish, datos incendios forestales. That means the data for forest fires. That's what the name says. It's in Spanish, so don't get confused. The numbers are never in a language. So even if you speak any number in English or in Spanish, you'll see the letter or the number one as one only. So don't worry about that. We'll see how we can come about this. So first of all, what I'll do is I'll open the Jupyter notebook because that's where I'll be doing this analysis. So Jupyter notebook. Okay. What I'll do is I'll open a new file. Okay, wait. I'll open a new folder. YouTube. Where is it? Okay, wait. We have I'll say alley white file. Let me try to import a few languages before I start my analysis. Import pandas as PD, import matplotlib dot pyplot as PLD, and import people as SMS. So we have our libraries with us now. What I'll do is I'll try to import that data set into this environment. So let me check what file type it is. Um, Let me see the properties, and I can see it is an Excel file. It is FLXX, so it is an Excel file. So the keyword I'll be using is pd.read Excel, pd.read underscore Excel. And what I'll be doing is I'll be writing the path over here. So let me copy it as a path and write it here. Okay, so we have the data set now. Don't worry about the language. I can see that there are a few column names that are in Spanish. Uh, don't worry, I know a bit of Spanish, so I'll just change the column names to the English names. Okay, so let me assign this data frame to a variable called df. So what I'll do is I'll print the first five rows just to get an idea about the data set. Okay, so this is how my data set looks like. These are the first five rows of my data set. Now, the first thing that I want to do is to make changes to the column names. So what I'll do is df dot or right, okay, df dot rename. Right. In this, I would have to pass a dictionary of all the values. So, so this looks like some temperature, right? Again, I mean, I know my audience is smart, so you might have guessed this is temperature, right? So let me change its name to temperature. Temperature. Okay. Then the next is humidity. Again, I know how intelligent my audience is, and all of those who might have or who are watching it from your homes might have recognized this as humidity, right? So humidity. Then moving on to the next, something called as velocidad VN2, that means wind speed. So let me change this name to wind speed. So the next, I forgot to add a round bracket at the start of this wind speed. Then comes días sin lluvia. That means days after rain. So which means the days that have been passed before the last time it rained over there. So this is some data I found on some website. Days, or you can say days without rain, without rain. So how many days have been passed without rain falling? So I think I got this data set online somewhere, and that was the closest I could get, which could help me understand what could be the reasons for this forest fires. So let me see. I don't know if this data is, I mean, real or not, or where is it from, but it can help me a bit. It can help me understand the reasons for forest fires or maybe um, wildfires a bit. Okay, then let me see. Then my next value is area vegetation. So again, now I know you are intelligent, but there are some words that are too tough to uh, convert if you don't know Spanish. So area vegetation means it's area of vegetation. That means the cover of forest, or if it's for forest, the cover of trees, or if it's a urban place, so it's cover of houses. The houses made from wood. So I'll say area covered. Area covered is good. So since area covered is in terms of 0 and 1, I think 0 means the area covered is less and 1 is area covered is more. So if the value is 1, that means more number of trees or more number of wooden houses are present over there. Okay. Next is riesgo incendio. That means a risk of fire. Risk of fire. That means it gives us a value. I think should be ranging from 0 to 100. I see 100 over here. Maybe more. We'll see. That means it explains us the risk of fire. So I'll just term it as the risk. And then comes incendio, which means did the event happen or not? That means did the fire took place or not? So let's see. Incendio. I'll say fire. I'll just give it fire. Fire sounds exciting, just like fireplace. Okay, so I'll mention the axis equals to 1, whereas and I also need to wait before committing to it. Let me see if it's working or not. So you can see it's working. You can see that the new column names have been converted to the English names. So I'll be better able to understand the data. So what I'll do is now I'll commit the changes by saying in place equals to true. Wait, there's a issue. Maybe okay. Somehow it did print true. Let me see that. Okay. But somehow the true came over here. In R only true. So let me see my first 5 rows again. And yeah, so now I have the column names as I wanted it. And I can see this video is pretty much already ready to perform an ML algorithm with because there are all the numerical variables, so there's no problem of having categorical variables. So far so good. It looks to me that there won't be any outliers, but still, let's have a look if it does. So SNS dot box plots. We use box plots. But before that, let's see if our data has some null values. So df dot is null. It helps us know if our data has null values. Um, okay, again, if I need to check how many null values it has, I need to use the sum method. And I can see there's that no null values in my data set. So I'm good to go on in that matter. What I'll do next is I'll check the box plots of all the data set. So I'll write over here data dear. And we can see that there are zero to few outliers in all of them. Zero to few outliers. So because we are studying over here, we don't need to be very precise over here. I don't think I need to do the outlier imputation right now. So I'll say it's good to go. And on the in the scaling terms, again, I won't be using scaling right now. And even the transformation, I can see that it's good to go except for the risk. But anyway, when I was thinking about this, I think the more the risk, the more the fire will be, uh, the chances of fire will be there. So I don't want to use this because this will just overfit my model. Because this will just simplify my assumptions, right? Because the more the risk, the more the fire. So the correlation of fire with risk would be a lot. Let's check how much is it. So I have a function called as df.core and I'll run it. So you can see what we want to predict is the outcome or the variable fire, right? So I'll see what the relation of the column fire is with each of these columns or variables. So fire with temperature is somewhere around 0.23. So there is some relation to it. And with humidity, it's minus. There's negative relation, but it is magnitude wise similar to what temperature is. I do want this value in my predictions, or I want these to be considered for predicting the fire. Wind speed is also slightly related to it. Even though the correlations are weak, I want them because I know that fire, the event of fire happening is heavily dependent on temperature, humidity, and wind speed. Because when I went through the news, I read a lot of analysts or a lot of scientists they were saying that these are the three very important factors that lead to these fires or propagation of this fire. Days without rain is highly related to it. So again, highly related to it because it's simple. It is days without rain. So maybe the rainy season. So the last rainy season was way back. So it's very simple. The assumption is very simple. So if I use this variable in my prediction, this will definitely increase bias. Definitely increase bias because I know this and risk, these two of them will definitely increase bias. So I am planning not to use these two in my predictions. So what I'll do is straight away I'll use temperature, humidity, wind speed, and area covered. These four input parameters to predict my fire. Okay. So now if you might be knowing how an ML procedure works, we are halfway there. We are almost halfway there. We're done with data pre-processing. Now we'll move on to modeling. So let's see. And now if my students are watching this, I would like to ask you what kind of variable is fire? Pause this video for a moment and try to think what kind of variable is fire? What kind of data type is it? And depending on that, I'll see what kind of ML algorithm I'll be using. Okay, so let me tell you, this fire is a classification type of variable. It is a discrete variable. So what I'll be doing is I'll be using it to classify. I'll be using classification ML algorithm to predict the fire. So there are various numbers of ML algorithms that I can use for classification process. But let's start with and say logistic regression. Let's start with logistic regression. Let's see. First of all, I would have to split my data set again. I would have to split my data set into two parts. So my x would be df dot drop. So what all columns do I need to drop? So first is days without rain, right? I want to drop this days without rain, right? Then comma. I want to drop risk and comma. I want to drop fire from my input because it's my output. So and I would like to search it in axis one. Let's see. Let's see what axis. So yeah, this is what my inputs should be, and I want my inputs to be. I will again I will define my y, which should be df dot fire. Let's see if it's working. So yeah, this is what I want. Okay. Now now we need to split the data set. So I'll be doing this process a bit faster because if I speak and do, it's gonna take a lot of time. So let's just skip the speaking part. I'll just do. And if you get confused about what I'm doing, just don't worry. You can just visit this video again to check what I was doing. So let me do this process really quick. So import from scalar dot model selection import train test split. Now if you are my student, you might be knowing what I'm doing, what I'm trying to do. So if you're not, don't worry. You can be in future. no much. So x train, comma, x test, comma, y train, comma, y test equals to train test split x y test size should be equals to 0.2 for starters, and random state should be equal to 0. Let's consider it 0 for now. Run. The name y is not defined. It says okay, right, because I need to insert the small y. Okay. Now what I'll do is I'll import leave from linear model. I'll import logistic regression. So from sklearn dot linear model import logistic regression, right? So once we do that, I need to create an object. I'll name an object name capital LR equals to logistic regression. I'll copy this thing over here, and I need to add maximum iterations as 10,000. And now I need to model this. I need to fit it into a model. So what I'll do is I'll write here lr dot fit, and in this I need to fit my x train and my y train. So I need to use my training data set to train this model. So x train is not defined. It says y, simple reason it's not defined because of this. And now it should be defined. Let me do this. Yeah. So we have modeled the model now. Now let's see. Now I need to predict it. So not fit, or sorry, not predict. My I need to give my testing values now. I can predict it. So this is what it has predicted for you. Now let's put it in y hat. Let's put it in y because those are my predictions. Let me check my score. So let me check my training score. That should be x train, comma, y train. Okay, so the training score that I got for this data is 89%, which is some fairly good training score. Let me see if my testing score is somewhere around this so that I know that there's no bias or variance in it. Let's see. X test, comma, Y test. Logistic regression object has no attribute test. Okay, oh, right, because it should be score over here. 0.9. So it's around the training data. It is safe to assume that there is the bias and the variance are equally balanced, almost equally balanced. I won't be needing to perform some steps to reduce underfitting or overfitting. So far, so good. Okay, so this is my prediction now. So it is safe to assume that we have created an ML model. So it's possible that this ML model might be working on the real data because I don't know about this data. This is some data that I got online, so I'm using it. But you understand how this process works, how first of all, what we did was we selected our problem statement, which was to know or to study how LA fire, how the reasons for LA wildfires. Okay. Next step, what we did was what I did almost was to check on the internet if there was any data available for it. So I did went to various sources I saw, and I got one of this data. It was very tough to find the data on that. Found I did not find any exact data on LA wildfire, but I did see some websites that do have this data. So maybe in future, if those websites or the people who are owning those websites are seeing me doing this, I would request them to provide us Fireblaze the original data so we can work on the original data and better predict this results, right? But yeah, anyway, so what we did was we got the data, we loaded that data into this environment and kind of pre-processed it to make it fit for our modeling. And then we modeled the data and we predicted the values and evaluated the model, how good it is performing, and we came up to the result that it is 90% accurate. Again, if the data would have been original, it's possible that we would have been able to predict it even better. Okay, so what I'll do is I'll separate it out. Okay, now what I'll do is I see here that this so there are four input in our modeling. First is temperature, humidity, wind speed, and area covered. So what we'll do is we'll try to input the actual values that happened in those areas on that date. So as far as my knowledge was, LA forest fires or LA wildfires started on 7th of January. So let's see, when did the LA wildfires start? Uh, when did the wildfire? So okay, so January 7th. Now what I'll do is I'll see what was the climatic conditions in that area on the 7th of Jan. So uh, Palisades. So Palisade, which is the other name for it is Pacific Palisades. Pacific Palisades. Weather on Jan 7th, 2025. Let's see if we get some data about it. Okay, so you can see there's this website called as uh, California Department of Forest and Fire Protection. Let's see, it has some data about these fires. Let's see if we get some interesting insights on it. Okay, so you see, this Palisade fires is just 39% content. This is live data, and around 23,713 acres of land has been consumed by this fire. And you can also see this in data. Wow, so you see how beautiful this data is. I mean, I'm not talking about news. The news is really saddening. Apologies for that, but the data is much interesting. So this visualization, you are able to see what areas are consumed by this forest or this fire. So date started, that is 7th of January, and these are the last updates. And so I would definitely want to get the data for this so that we would be better able to learn the data to avoid scenes like this or avoid these things in the future. You can see there are evacuation orders and evacuation warnings still going on because there's again there are more chances of these fires happening. Okay, that's it. I don't see any data over here, but I would definitely would have been happy if I saw the data over here. Anyways, because data are private, so we cannot always count on data website to provide you the data. Okay, temperature. Let's see. If I get temperature data. If there's something called as like where I know this might help me. January 7th was. So this happened somewhere around 10:30 a.m. So I would have to see what temperature was there at the morning 10:30 a.m. in that area. But I'm not able to view this correctly. Let's see if this will help me. Okay, it's not found. Let's see, let me search Palisades over here. Palisades, California. California, Palisades Enviro, not the one in New York. Okay, let's see Los Angeles then. Let's try to figure it out by Los Angeles. Los Angeles's data because it is from there. I want it for 7th of January. So let me see. Let me see. We'll go here. Price. I'll say Los Angeles. Angeles weather. Los Angeles weather. No, no. Oh, Los Angeles weather on 7th of Jan. I mean, it's not helping me. This thing is not helping me. Um, wait. Okay, there's now we're talking. Now we're talking. Now we have some data over here. This is for 7th of January, the temperature and the wind. Okay, so I have temperature and wind and possibly humidity. Yeah, I have humidity. So okay, now good. We have our data. Let's try to predict the fire on that data. So what I'll do is I'll use LR dot predict. Right. So we predict using X test. So let me see how X test looks like. So this is how X test looks like. What I need to do is pass a list for this. So let me add a cell above and okay. So LR dot predict. Right. I need to pass an array over here or maybe a data frame. But let's see if I can do it with a list. If not, I'll change it to array using NumPy. So I would have to import NumPy again. But okay, temperature was 17.3 degrees maximum and 11.4 minimum. So let's say somewhere around 15. Let's assume 15. So at 15. Okay. Again, we are just learning, so I can do this kinds of assumptions, right? Humidity is 41.7. So it was a bit dry on that day. 41.7, that means 100, a relative humidity of 100 means it's almost raining like conditions. And the lesser the humidity is, the drier the conditions are. And always make sure that if the conditions are dry, there is a possible of these fires. I'll also discuss one thing that I noted about this, and I'm not sure why no one talked about it yet. And the wind speed was 14. Okay, again. Wind was a lot faster on that day. A lot faster. And the area covered, let's say it's a urban area. So let's say zero for now. Let's see if we can predict it. Okay, it says that there's some kind of error expected to be here. Okay. So it expects a 2D array over here. Let me add it in terms of 2D array. Now you see the output here is 1. That means there was huge chances of fire already. So again, I'm not doing anything new. This was already done by the climate people in in that area in California. They already knew about it. They did predict it. They might have used this kind of ML algorithm before. What I'm saying is, this is what we have or we data analysts do. We analyze the data. We try to predict the data to get insights like this. So now I have created a model that can predict chance of wildfire in places in any place. Right? This is not limited to California. This is just climatic condition, and these climatic conditions can be anywhere in the world. So wherever these kinds of climatic conditions occur, there's a huge chance of wildfire. But now some of you might be saying that these kinds of wildfire or these kinds of climatic conditions are even worse in places in India. Or what? Let alone India, in Nagpur. In Nagpur, the temperatures go as high up to 45 degrees, and the humidity goes down to 30, down to 20, and the wind speed also goes somewhere around to 10. So why don't incidents like this happen in India or in Nagpur? So one huge reason for that is the houses. the house is made in India or Nagpur because it's already a tropical country. Is it? I don't know, but it's a hot country, you know. So we already know that if we make houses from wood, it will catch fire easily. So that's why we make houses of concrete. But in USA, people have different kind of problem, and that's why their main concern is to create a house made up of wood. Okay, so but yeah, so we have successfully created a model that could predict chance of wildfire happening. Okay, so now let's see. Just a second. Okay. So let me open up an Excel sheet. Now this is just this. Okay, need to activate it. Okay, this is just a fun activity. It's not anything serious. We just did whatever we had to. हमको जो करना था हमने किया है. It is some the not fun activity, just for our information. So हमने क्या किया? What we did was we predicted the occurrence of a wildfire successfully. Okay. Now you might be wondering why I'm writing this. This is just for my this is like my diary. I'm just writing what we did today. We learned, and I'm also suggesting you to maintain an Excel file or a diary like this to remember what you studied, especially in these YouTube videos or this YouTube lives. I'm expecting you would write something like this, and so that if we meet somewhere, you can tell me what all you learned from it, right? Okay. So, okay. So we learned about the forest fire, the wildfires. These are not forest fires; these are wildfires that happened in Palisades and Eden. Okay, so both Palisades and Eden are both areas of Los Angeles. So as long as we have predicted it for Los Angeles, we have predicted it for both Palisades and Eden. Now it's also a bit it's also a bit concerning for me because this is not just these regions, Palisades and Eden, that is under the risk of this, but the whole Los Angeles is under the risk of this. And this is happening when the the area covered, the vegetation is less, right? So let's see if the area of vegetation would have been more. I don't think so. I would have to even think about it. It would definitely save one because as long as the forest fires are taking place in the area where the vegetation is less, it will definitely take place where the area of vegetation is more. So it concerns me. Let's see about let's see. So now today is what? Today is 18th of January. Let's see the data for next week. So is there anything on 19th? So there's conditions like this available on 19th. Let me try to predict if it's gonna be worse conditions over there. So let me copy this and let me paste it here. And okay, so temperature it says should be what? Should be around between 18 and 12. So I will say let's assume it to be 14. Let's assume it to be 14. And then comes the humidity should be around 45.2. Again, 45.2 is considerably dry. 45.2. And the wind speed should be 12.7. Again, some high wind speed and the area of vegetation is 0. Delete 0. Again, the chances of wildfire is still 1 over here. So that's the reason when we saw over here, we saw that these evacuation orders and these evacuation warnings are still on because the risk is still prevalent over there. The risk is still prevalent. That's why people who are residing over in Palisades or in the whole of Los Angeles need to be prepared. You don't need to panic, but you need to be prepared, right? Okay, so now this comes to the end of my predictions. Okay, we did that successfully, right? So let me see what the time is because I cannot take a lot of time of your because we are already late for this live. And I hope this will happen in future. I will try to be on time because we are new to this domain. We don't know how to do this system, but we did try figure out successfully. But yeah, we will try to be on time from the next time. But let me let me talk to you guys about one key one key observation that I observed or that I saw that no one is talking about. I mean, why this winds increase all of a sudden? So I read somewhere about Santa Ana winds. Santa Ana winds. So Santa Ana is basically a city, yeah, around the Southern California. And what these winds do, these winds they come from desert. So there's a huge desert outside California towards Nevada. There are huge winds that flow. So you can read that this Santa Ana wind, occasionally referred to as the devil winds, which is they are that strong, they're extremely dry, right? So you see, if the wind's strong and it is extremely dry, what does it indicate? It is a party for a fire. If there's fire, the fire would be happy because it will be able to spread very quickly, and that's what happened there in Los Angeles. So it was an unfortunate event, unfortunately because of these winds, Santana winds. But there's one more thing. I don't know why no one's talking about it. I did, I did came across this because it happened when I was going through internet, surfing through internet in October or November. There was a huge, buzzword called as La Nina effect. Do you guys remember La Nina effect? Or remember something about that? So La Nina effect. Have you have you ever come across this word? So according to the news in October or November, I heard that the winters over here are gonna be very very cold. So I heard that even in February there will be cold, and there was gonna be snow in many parts of India, and it also did snow in some parts of Hyderabad or Bangalore where it never snowed before. It was weird, and they were giving the credit to La Nina effect because of that. So I was wondering, this La Nina effect, it brings cold, right? So why is it bringing dryness over there, or why is it not bringing some cold over there? So I went and I researched about this, and there was one. So on this website, I saw there are two kinds of effects called as El Nino and La Nina. So what happens? These trade winds. What are trade winds? So basically, these are the winds that are traded between continents. So when these trade winds they move towards west, what it does is it brings all the top warm water towards the west, creating a void in the eastern part, and brings all the cold water that is situated at the very bottom of the sea upwards toward the eastern side where it happens that this cold water causes the temperatures to go down in the eastern part, which is called as La Nina. And opposite to that, when it happens, the water or the cold water upwells from to the western side, and it tries to create the colder temperatures in western part of the Pacific Ocean. That's called as El Nino. So you can see this thing. So when El Nino happens, the stream it goes towards the Asian part, and because of the tilt of our Earth is tilted somewhere around 23 degrees Celsius, not Celsius, sorry, it's tilted around 23 degrees. Because of that, the southern region of USA suffers of better parts. And when El Nino happens, you might be hearing a lot about floods. A lot of floods happen in the southern part because of this extreme cold weather, or extreme water, or extreme rain. And the up northern parts are a bit warmer when El Nino happens. But when La Nina happens, you can see that the northern regions in USA get colder compared to the southern regions. They get drier, they get warmer, right? So California is situated somewhere around here, and you can see that when La Nina happens, the this thing gets drier. So so can you imagine this region and the La Nina that happened this year? It is said that the magnitude of this is three times what a normal La Nina is, because you can go and read about it. There's always, after a few years, after 20 to 21 years, it happens that the La Nina that comes is always the three times the magnitude of what happens each year, or it happens every 2 to 7 years, somewhere around that. But after every 20 to 21 years, when the La Nina happens, it is three times the intensity. And the last time it happened was in I think 2000 or 2001. We can go and research about this, but this is the case over here. So you can see. So the La Nina plus the Santa Ana winds, that was the double trouble that the people in Los Angeles are facing right now. So you can imagine how dry the weather would be there, and that too, the very fast flowing winds. I mean, if you stay there, if you stay in Los Angeles, if you stand in these kind of environments, you'll be really thirsty really quick, because it will just suck every water molecule inside your body very quickly, because these are dry air and fast moving airs. Okay, so this is, and I don't know why no one is talking about it, but I think I figured it out. Or I think that La Nina is one of the reasons. Again, with this Santa Ana winds, that is the reason for this forest fires or the wildfires. Okay, so yeah, so this is what my plan was for this YouTube live. So now, are you getting a bit of an idea how the critical thinking works in data analysis, and why is it important, and why data analysts play an important role in the world, right? Because these are the data analysts who analyze this kind of situation. Maybe the field they are in might be different. Maybe they might be in climatic fields, maybe geological fields, maybe in various fields such as medical fields, maybe healthcare fields, or maybe in finance fields. So data analysts, they work in various fields. Okay. But in whichever field they work, their purpose is solely to analyze the data, to draw out insights which will help us predict or prevent such dangerous situations, or what maybe prevent anything. For example, if it's in a healthcare industry, it will studying this data and predictions might help us predict what kind of disease someone might be getting in future, and that person can be warned beforehand. Stuff like that can happen with, if you know how to analyze the data. Okay. Okay, so this was everything for this video, and I'm hoping that you guys have liked this session, or you at least got something to learn from in this video. Okay, let me see. Let me see if okay. Okay, so somehow, just give me a moment. I'll see if there are any comments and I can reply to them. Okay, there's comments I see. Okay, so there's one Samitha. I don't know if you are a he or a she. I'm sorry for that, but It's good to see you. Thank you, Samira. Thank you for that. And Vaishnavi was saying that the session was good. So thank you, Vaishnavi. And there's Pratik. Pratik says, thank you for the session. It's really helpful. You are welcome, Pratik. And I hope you would be seeing these kinds of session coming forth. We'll try. I mean, I'm not hoping. I'm planning. We are planning to do such sessions more and more. And I'm expecting you all to show in a huge crowd. But for now, I would like to sign off, and I would like to thank you all for attending this video. And if you like this video, you can also check out other videos on our channel and and get more knowledge about the data science. Thank you.